students, welcome to All Things Pharmacy. Today we're going to be talking about adrenergic agents. Adrenergic agents are agents that stimulate or depress adrenergic receptors. There are different types of receptors, namely the alpha receptors and beta receptors, and those two are further subdivided into alpha 1, alpha 2, and then beta receptors are subdivided into beta 1, beta 2, and beta 3. These agents, they have a chemical group that has the name phenylethylamine derivatives. This chemical group is very common amongst adrenergic agents, and an example of an agent that has this, or that was synthesized based on this phenylethylamine, is adrenaline. These agents are called phenylethylamine derivatives. The first one is adrenaline. Adrenaline is naturally found in the body, and it is produced in response to a flight or fight that happens in the body. It is produced naturally in the medulla, and it is a hormone. It can be used as a hormone or as medicine. When it is used as medicine, it is usually produced synthetically. It is synthesized synthetically, and when it is synthesized, it is produced in the form of both the dextrorotatory and the levorotatory isomer, and they are separated using fractional precipitation. The levorotatory isomer is the one which is more potent and the one which is usually used as the medicine. Moving on to the properties, adrenaline reacts with acids to form salt, and this salt decomposes in solution. It is unstable in neutral or alkaline solution, which can lead to oxidation, which produces dark colored impurities. This happens because of the catechol nucleus, which has the OH groups which are reactive. Because of this, because the salts decompose and it's unstable, this leads to a short duration of action of adrenaline. Adrenaline can also not be administered orally, which is the limitation, especially when it is to be used as a medicine. Dilute solutions of adrenaline are partially stabilized by addition of chlorobutanol and by reducing agents such as sodium bisulfate. Adrenaline as a medicine can be used to treat anaphylactic shock. It can also be used to decrease intraocular pressure in chronic open-angle glaucoma, which is an eye condition. Another example of an adrenergic agent which is also a phenylethylamine derivative is isoprenaline. Isoprenaline reacts with light and air. It is administered sublingually and it is used to treat asthma. It can cause intense stimulation of the heart muscle. If you look at the structure, you can see that it is very, very similar to the structure of adrenaline. The only difference is the last group that is attached to the nitrogen. For the isoprenaline, there is a propyl group, and for adrenaline, there is only a methyl group that is attached to the nitrogen atom. And so they will have similar properties, like they're both subject to oxidation, and they both cannot be administered orally. Now we're going to move on to the structure-activity relationship in the sympathomimetics based on phenylethylamine. And now we're going to be looking at the skeleton of the phenylethylamine derivatives. all of the derivatives, they have these basic chemical groups, which is the benzene ring, 2 carbon atoms, and also the amine group at the end of the chain. For them to have optimum press activity, there has to be 2 carbon atoms between the amine group and the benzene. And also the activity of the phenylethylamine derivative is going to depend on whether it's a primary amine at the end, a secondary amine, or a tertiary amine. The primary amine is more active and less toxic, which means that the less R groups, the more active and the less toxic. If it's a secondary amine, it's going to depend on the R group attached to the nitrogen atom. It's going to depend on the length of the alkyl group or the aromatic group attached to the nitrogen atom. The longer the group attached, there's going to be a decrease in pressure activity. For example, if you go back to those two structures of isoprenaline and adrenaline, based on what I just said, it means that the press activity for isoprenaline is going to be less as compared to adrenaline. So we expect adrenaline to have more pressure activity, and the tertiary amine will be very, very toxic, which is why it hence not very common amongst these agents. Now we're going to be discussing the phenyl part, which is basically the benzene ring. We're going to be talking about what would happen if, for example, we add an OH group, a hydroxyl group. This would increase the press activity of the derivative of the amine. However, the number of the hydroxyl groups added matters, and also the positioning of the hydroxyl group also plays a role in the activity. Mono substitution, which is when there's only one hydroxyl group, results in less activity. The activity is less effective than if there was 2 hydroxyl groups, and if there are 3 hydroxyl groups, there is activity. However, there is a high potential of having adverse effects, which is what we try to avoid in terms of medication. The positioning of these groups can either be meta, para, or ortho. And here I have a diagram that shows where the ortho positioning is and the meta and the para. So the R group that I have put on this diagram, it represents the 2 carbon atoms and the nitrogen, the amine part, which is basically the rest of the phenylethylamine derivatives. I just put it this way so that it's easier for us to look at. In terms of the positioning of the hydroxyl group, the meta position is more effective than the para, and it's more effective than the ortho. But since the dihydroxyl substitution is what is the most effective, the meta and the para positions are both used, which is also what is in the adrenaline structure and the isoprenaline structure. These hydroxyl groups are on carbon atom number 3 and number 4. Compounds that have 3 carbon atoms in the side chain are more active orally than those that have only 2 carbon atoms in the side chain. As you can see in the diagram, that this compound has 3 carbon atoms directly attached to the phenyl group or the benzene ring, as compared to adrenaline and isoprenaline, which I have also just previously mentioned that adrenaline is not administered orally, and that is due to the fact that it has two carbon atoms attached. There can also be a methyl group attached to the alpha carbon position. The alpha carbon is the carbon that is directly attached to the functional group of the compound. So here the functional group will be the amine group, and the next carbon that is attached is known as the alpha carbon. Compounds with methyl group on alpha carbon position are active by oral administration and have stimulant action on CNS, like the isoadrenaline, as you can see the diagram. The methyl group on alpha carbon also causes a depressor activity and increase in toxicity in comparison with the parent compound. Thank you for watching. We have come to the end of our lesson. Until next time.